Good afternoon, everyone. I'm Farid. Today I'm going to present my thesis project entitled Small Scale Waste Collector System, supervised by Dr. Steve Bergmann. In this presentation, I will touch 12 things, which is project context, aim and objective, design process that I have implemented, market research, product design specification, pattern research, initial design ideas, design selection, detailed design and optimization, then which is include failure mode element analysis, failure mode effect analysis (FMEA), and design for manufacturing and assembly (DFMA). I also will come up with the final design at the end of the presentation. So to put the project into context, this project is actually a continuation between the collaboration of Bergmann Direct, which is a UK-based company that design waste and management solutions with the University of Sheffield. So I need to fit the design within the business focus of Bergmann Direct and also meet the requirement of the University of Sheffield. This project is actually about designing a product that actually fit between the product lines of Bergmann Direct, and it has been done since September last year, which total up to 7 months. And the opportunities are actually, I've been given the opportunities to choose my own market research, market that I will need to focus for the product, and as well, because this is for domestic use, so I'm bound with the law and regulation as well as safety standard. So the aim of the project is actually to find install waste management solution that that will increase customer experience, reduce the overall cost, as well as environment friendly. So the objectives are to find the feasibility of fast food restaurant as a market segment, to look for products that are already available in the market, understand the current approach that is being used in the fast food restaurant nowadays, evaluate the true needs of the customer, the clients, and develop a viable solution. So throughout the project, I've implemented the design process, which actually altered from part and build theory as well as the little book of design. So I combined these two to fit within this project. So the first thing about this project is obviously about market segmentation, which actually I spent the first 2 weeks to find the right market for the product. And I came up with the fast food restaurant. Why? Because it's from Daily Mail UK, it seems that in UK, in average, people spend £1,300 for fast food every year. And for those at the age of 25 to 34 years old, they spend over £2,600. To put that in context, actually the amount that we spend in UK for fast food restaurants, for fast foods, actually double the per capita income of India. So that is how good the market is. And if you look into the market segmentation as well, the market size has been developed throughout the years, and based on the recent research by University of Cambridge, it seems that currently there is about 13,000 outlets that we can look into. So, since we are confident that this is the right market that we want to develop a product for Bergmann Direct, I then go to the fast food restaurants in Sheffield, in the city centre, such as McDonald's and KFC, and talk with the staff and the customers, and I found that 81% actually feel uncomfortable when they need to see that the staff need to empty the bins. 78% have seen this process of emptying the dustbin more than twice out of 10 visits. 31% actually experience this scenario that actually the bins are full when they want to throw their trash, and 84% actually have to wait for the staff emptying the bins. This is conducted based on the survey that I've done for 34 people, and actually the survey has been proved by the ethics of the Sheffield department. And the second research actually include by looking into the available products in the market, and that includes medium-sized waste compactor and small-sized waste compactor. And some of the products are Tony TT100, Whirlpool Under-Counter, Incinerator, and World Daily Trash. So I've looked into this product, looked at their performance and specification, and tried to look for the advantage and disadvantage. Then after all this information about the market research, I came up with the design objective using the objective tree analysis, and I came out with a high completion ratio, 24-hour continuous operation, easy maintenance, etc. And based on this design objective, I then developed a product design specification that actually includes 10 elements: performance, environment, product lifespan and service, reliability and maintenance, refurbishment and disposal, target cost, ergonomics and user autonomy, manufacturing process, legal and patents, and size and compatibility. I'm not going to go through each of the components, but then there is 4 things that I think needs to be highlighted. First, the system must be capable of storing 480 liters of uncompressed waste, which is equivalent to 6 times the 80-liter bins that we use nowadays. The system should not infringe any patents. In the European Union, the dimension has been established based on the average bins that are currently being used in the fast food restaurants. And the operation cost should be lower than the minimum man-hour cost. And since nowadays, there are 8 million patents that have been patented, so it's very likely whenever I want to develop ideas, the patent is already being patented. So what I need to do next is actually I put a patent research first. So I look into the patent and you can see the relevant patents. We also know that patents can last up to 20 years. The design utility patent can last up to 20 years based on the US patent law. So this is some of the patents that actually within the past 20 years. So we have the universal manual trash compactor, actually using the hand to pull the arm to compress the waste, which is also similar with manual operated trash compactor. The waste compactor, this one actually used something like binocular screw to compress the waste. And you also have vacuum trash compactor, actually suck the trash from the bottom to compress the waste. So this is some of the patents that we patented. So based on rough idea of the needs based on the product design specification and the patents that I've looked for, I come up with the design ideas, and there are 6 design ideas that I'm being looked into. And the first design ideas is actually using shaft and a cone roller shape. So as this shaft moving downward, it compresses the waste. The second one, this is the most straightforward, I guess. You're using press plate and connect to the shaft. It could be hydraulic or actuated. The third one, using crusher. So as the waste is inserted, then the crusher will actually crush the waste and make it into smaller pieces before it comes into the storage. The fourth one, using press plate. Rather than using a horizontal press plate, this vertical press plate will actually compress the waste from the side. And the fifth one, using ram system. So we use the scissor ram to transmit the force from the actuator, the fork, to the press plate. And the last but not least, using press plate, but rather than using a horizontal press plate, we actually pivoted the bottom part of the press plate, so as it moved, it swing down and prevent from any spill of the waste. So since we now have 6 design ideas, I need to select one out of these 6. So using the most basic concept, I list out all the product design specification and compare each other between these two with score 0 to 1, and I come up with the scoring and the weightage. I then use this weightage to compare all of this design with the product design specification with a score of 1 to 5. And again, I come up with all the scoring and come up with the best design, which is design 5. Now we have design 5 and we look into each of the components. So the next part is actually I have to detail all the design and make the optimization. And this optimization, actually I've been using 4 methods. The first one, most of the calculation, which is very simple, will be used using Excel. So I plot the graph, everything using Excel. For FEA, finite element analysis, where I need to study the stress distribution, work versus theory, looking for the deformation effect of safety, I'm using SolidWorks. And to look for material, which actually I can compare the cost and the ultimate tensile strength, I'm using the CES EduPad. And after all, this is all the theoretical data, so I have to look into the market as well. So what I did is actually I try to look for the current available suppliers for each of the material that I'm going to use. For example, this is the mainframe, so we need to support, the mainframe has to support the weight of the whole assembly. It also needs to withstand the reaction force as the compression occurs, and it must be provide a suitable physical appearance. So what I did is I come up with a simple design that meet the product design specification, PDS. I look into the stress distribution, and as I start to see which part have less stress and which part have more, and after I do the optimization and come up with the frame structure design. So this one is actually, you can see we can reduce a lot in terms of material volume, hence we reduce material cost. At the same time, we still keep the deflection effect of safety at a reasonable point. And again, for actuator and scissor rep, also, this time, what is very important, because we know the actuator will act in horizontal direction, and the reason is for that is because we're going to put at the top and we want to actually save some space. And this actuator which act in the horizontal direction will actually push the press plate in the vertical direction. So I did a bit of mechanics calculations, come up with that equation, and we can see actually the force will highly dependent on the degree angle of the ramp. So I need to check which is the best part of the working angle. So I look into the extension, and from the FMEA, failure mode effect analysis, and the FMA, I also know that it's very crucial to minimize the number of parts. So you can see this is the second, this two-stage ramp, this is the three-stage ramp, so we also compare that as well. And after we have come up with the best, I guess, which is two-stage, and we look back again into the von Mises stress distribution and also the deflection. So this is the final design. I'm not intended to design the actuator by myself because it will require more effort and very pricey. So instead, I looked into potential suppliers and decided between one of these two. Again, the same thing happened with the storage. So what I did is come up with a simple design, do a bit of deformation and stress distribution, and come up with a better design that can actually reduce the cost. And also you can see I have changed the material accordingly. And the same thing for press plate. Come up with a simple design, study the deformation and also the stress distribution, and come up with the optimized design. And apart from that, there is the mechanical part. I'll also consider the control system, which actually will help the system to work coherently. So the control system will include control board, depth sensor, door lock, LED indicator, and this is the process. I'm not intended to design the control system by myself, but I actually have found a few companies, mostly those that produce the actuator, manufacture the actuator. They also supply control systems, so we just need to do a bit of programming for that. And again, include in the optimization in FMEA, failure mode effect analysis that I mentioned before. So for example, the press plate, we know that it's trash leaking because of hygiene issues. So you can see, because of this, actually we changed the design of the press plate. Rather than put a cut through on the press plate, we put another one aluminum sheet at the bottom to prevent it from sticking. Again, we do the optimization based on the FMA as well, design for manufacture and assembly. And this is actually from the initial design, and this is the optimized design. So we reduce the theoretical minimum part by 30%, assembly time reduced by 37%, theoretical part count efficiency increased by 8%. So even though it's not that much, but if we assume that we're going to produce 100 units to 100 units, then that will sum up to quite a lot. So this is the optimized design from the outside. You can see this is actually we use wood rather than plastic for the housing, for the environment concern. And the inside part is this is metal and this is plastic. The exact material is listed in the thesis. And this is the inside of it. So we have the ram actuator at the top and the press plate. So again, this is the part. And this is how it works. Isn't it moving? Wait a second. Right, so this is how it works. So it will actually extend to half of the storage. Here's a bit of the references. And I think that's quite fast actually. I tried to rehearse it suddenly it's spoiling. Thank you.
Right, thank you very much.